Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we will discuss some more programs on loops. In the last video we studied some basic programs on loops and if-else statement. Now we'll have a look on some more programs on loops. Now the first program is to generate the Fibonacci series. Now before going to a program, first we will understand what is mean by Fibonacci series. Now your Fibonacci series always starts with two numbers, they are 0 and 1. And after that the third number which we get, that number is addition of first two numbers. So let us first draw a Fibonacci series. Now suppose if I am drawing a Fibonacci series of first 15 terms, then how it will be? I will start from 0. Then my next term will be 1. So my next term, I mean my third term, will be the addition of first two terms. So it will be 0 plus 1, 1. Then my next term is going to be 1 plus 1, 2. Then my next term is going to be 2 plus 1, 3. Then my next term will be 3 plus 2, 5. And then 8 and then so on. So we'll see how to write a program to generate the Fibonacci series. Now in this case I have taken three variables. Now see, all my three variables are of which data type? Integer. It means what? They will take numbers without decimal point. So how to declare a variable? We declare a variable along with the data type. So that is integer is my data type, f0, f1, f and n. These four variables I have taken. Now f0 is to denote the first term. So my first term is 0. So I am writing here, this is my f0. f1 is equal to 1. So my next term is 1. So my f1 is equal to 1. Now the third term which I will get, I am naming it as f. So my f is going to be what? f0 plus f1. In the next thing, what I'm doing is I'm first printing my first two terms, because my first terms are going to be what? 0 and 1. So I can print them as it is. So see out Fibonacci series f0 and f1. So what I have done here, I have printed basically a two terms, that is what? 0 and 1. So my f0 is 0 and my f1 is 1. I have printed both of them. Now I have written endl everywhere. It means what? My terms will get printed one after the other. They won't get printed in this straight line. They will get printed one after the other, or you can say they will get printed in the different lines or the separate lines. Now the next what I will be doing is I will be calculating the third term, and your third term is going to be what? Your addition of first two terms. Now see, in this case what I will be doing, I will be generating Fibonacci series repeatedly. So it means I have to make a use of what? Loop in this case, because you will be calculating the sum repeatedly till your condition gets satisfied. Now in this particular program I am calculating a Fibonacci series of first 15 terms. So it means what? I have to do the things repeatedly, so that's why I have to make a use of what? Loop. So which loop I have used here? Yes, for loop I have used here. Now see, for n is equal to 1 and n is less than equal to 13. Now see, in this program I am calculating the Fibonacci series of 15 terms. So I have written what? N is equal to 1 and n is less than equal to 13. Why 13 only? Because first two terms I have already got, that is 14 and 15 term I have already got. You can say they are 0 and 1. So that's why now how many terms are left? Now 13 terms are left. So that's why n is equal to 1 and n is less than equal to 13. And every time you will be incrementing the value of n by 1. So what will happen here? I will be calculating the third term, that is f, and your f is going to be what? f0 plus f1. So I wrote here f is equal to f0 plus f1. And then what I will do? I will print the value of f. So in this case I got my first term which is fixed, that is 0. Then I printed 1. Now I am printing the third term, that is f, and my f I also got as 1. Now next what will happen? Now your terms will get exchanged. Your terms will get exchanged means what? Now in the next iteration your f1 will become f0 and your f will become f1, and this is going to be your f. So for that what I have done is I have written f0 is equal to f1. It means what? Now your f1 ka value will go inside the f0 and your f ka value will go inside the f1. I am writing over here again. See friends, it was like 0, 1, then I got my third term, that was f1. Now the next term is going to be 1 plus 1, 2. So initially this was f0, this was f1, and here I got f. Now in the next iteration this will be your f0. So I wrote f0 is equal to f1. This will be your f1. So I wrote f1 is equal to f, and this is going to be a f. So it means you have to exchange the terms. So in the next iteration, it is going to be a f is equal to f0 plus f1, and I got what? 2. So again I will print the value of f. Now again you will increment the value of n. Now your n will become what? Your n will become 3. So here 3 is again less than equal to 13. So one more time you will go inside the loop, and again you will do the same thing. Now in this case, this is going to be a f0, this is going to be a f1. So what f I will get here? 2 plus 1 is 3. So this is going to be a f. In the next iteration, again the products, I mean the terms will get exchanged, and this will be your f0, this will be your f1, and then I will get f as what? 5. So I will keep on doing the things till my n is equal to less than equal to 13, and at the end of the loop I will be getting 13 Fibonacci series. I mean first 0 and 1 included, so I will be getting 15 Fibonacci series on my computer. So this is how I generate the Fibonacci series, and this is how I write a program to generate the Fibonacci series. We'll have a look on to this program again. I took 4 variables. They are f0, f1, f and n. The f0 and f1 are to initialize the first 2 terms, and they are 0 and 1. Then I printed f0 and f1, and then I will be going inside the loop. So I started from n is equal to 1, n is less than equal to 13, because altogether I am printing 15 terms. 2 terms I have already got, they are 0 and 1. Now 13 are left. So I will start from n is equal to 1, n is less than equal to 13, and every iteration I will be incrementing the value of n by 1. Now the third term which I will get, that will be f, and f is equal to f0 plus f1. After my n ka value will get incremented, I have to exchange the terms. I have to exchange the terms means what? My f1 will be f0 now, and my f will be f1 now. So you have to keep on doing the things till my n is less than equal to 13, and this is how I generate the Fibonacci series. So I hope you have understood the program of Fibonacci series. Now the next program is to test whether the entered number is prime number or not. Now basically in the prime number is a number which is divisible by itself. So we have to calculate, or we have to check whether the entered number is prime number or not. So we'll see how to write a program to check the number is prime or not. So see, here I took 2 variables, that is prime and c. So prime is a variable in which I will be entering a number to check whether that number is prime or not, and the c is, c is a variable just to check whether the number is prime or not. So initially I have initialized the c ka value as what? 0. Then I am telling user to enter a number. Now whatever number the user will enter, that I am storing inside the variable prime. Now suppose if user enters 5, then 5 is a prime number because 5 is divisible by itself. Now how will I check whether my number is prime or not? So here I have made a use of for loop. Now we'll see how to execute the program. Now for I is equal to 2 and I is less than prime, I have started from, initial value of I have taken it as what? 2, and I is less than prime. So the number which is entered by user is what? 5. So my prime is 5 here. So I will be executing the loop till my I is less than 5. Now initially here I is what? 2. You have to go inside the loop till my I is less than 5, and every time you will be incrementing the value of I by 1. Now initially here I is equal to 2. I will check whether 2 is less than 5. Yes, my 2 is less than 5. Then I will go inside the loop. Now what is written inside the loop? If my number is divisible by 0, then set c is equal to 1. So what I will do? I will divide my 5 by 2. If I will divide my 5 by 2, my c is not going to be a 1, because I won't be getting the remainder as 0. So again I will increment the value of I by 1. This time my I ka value will become what? 3. So one more time you will check whether 3 is less than 5. Yes, 3 is less than 5. So again you will go inside the loop. Again you will do the same thing. First what I did is I divided my 5 by 2 and it was not 0. Now you will divide your 5 by 3. Again it won't be 0. So your c ka value will remain as it is, that is 0. So your C ka value will remain as it is, that is 0. Then again your I ka value will get incremented by 1. Now this time your I will be a 4. Now 4 is less than 5, yes. So again you will go inside the loop and again you will try to divide your 5 by 4. Again your remainder is not going to be a 0. So again more time you will increment the value of I by 1. This time it will become 5. Now 5 is not less than 5, it is equal to 5. So you have to come outside the loop. Now if your C is 0, then your number is what? Prime. So in this case my C ka value didn't change, it was 0 only. So I will print my number is what? Prime. So in this case what I did basically, when I entered 5, when I wanted to check whether 5 is prime or not, I started dividing my number by 2, then I divided my number by 3, I divided my number by 4. So it means what? I tried dividing my 5 by every number till 5, and if it is not divided by any number, then I will be considering my number as what? Prime number. For an example, if I will take another number as 7 number, then what I will do, I will try to divide my 7 from 2 to 6. If my 7 is not divided from 2 to 6, I mean if my 7 is not divided from any number in the range of 2 to 6, then I will treat my number 7 as what? Prime number. It means what? Yes, 7 is divisible by only itself. So this is how we check the prime number. I mean this is how we check whether the number is prime or not. So I hope you have understood this program. Now the next program is to check whether number is palindrome or not. Now first we need to understand what is mean by a palindrome. Palindrome means what? If the number, if you reverse the number and if we get the number as the original number, then we treat that number as what? Palindrome number. For an example, 11. 11 is a number. If you will reverse the number, again you will get what? 11. 22. Again if you will reverse the number, you will get what? 22. 33. Again if you will reverse the number, you will get what? 33. So these numbers are called as what? Palindrome. But see 21, if you will reverse the number, what you will get? 12. So it means what? My 21 is not palindrome. So palindrome is a number in which the reverse of the number is what? Original number. Then that number is considered to be a palindrome. So we'll see how to write a program to check whether number is palindrome or not. Now in this case, I am telling user to enter a number. Now suppose if the number entered by user is 55, then what I will do, I will assign that 55 to variable dn. I mean dn is equal to n means what? The n ka value, whatever you have entered, that will get transferred inside where? Dn. Now what you have to do, dn is not equal to 0. Till your dn is not equal to 0, you have to do the following steps. Now what exactly you are doing is, you are dividing your number by 10. But when you are dividing your number by 10, first you are collecting a remainder of the number inside the variable d, and then you are collecting the quotient of the number inside the variable dn. So how to do exactly? I took my number as 55. Now I will divide my number by 10. So how it will be? If I will divide my number by 10, then it is going to be a this. So it means what? I got remainder as what? 5. So it means my d ka value is going to be a 5. And my dn will be what again? What I got? Quotient as what? 5. So again my dn is going to be what? 5. And what my temp ka value will be? So temp is equal to temp into 10. Initially your temp is what? 0. So it is going to be a 0 only. So 0 plus my d is 5. So your temp is again going to be a 5. Again what you will do? Again you will go inside the loop. Now my dn is what? 5. It is not 0. So one more time you will do the same thing. Now you will divide it by 5. So it is going to be what? 5. 10 divided by 5. So it is going to be a 0 minus 0. So again I got remainder as what? 5. So in this case again I got remainder 5 and quotient what? 0. So what you will do? D is equal to dn module 10. Now in this case my dn was 5. So I divided it by 10 and I got the d as what? 5. So again in the second iteration my d is going to be a 5 and temp is going to be a temp is equal to, now temp into 10. What I got temp in the previous iteration? Yes, it was 5. So 5 into 10 is going to be what? 50 plus here d I got is what? 5. So here temp is going to be a 55. and now your dn is going to be what? In this case I have to collect what? Quotient, and my quotient is what? 0. So see, again I will go inside the loop now, but at this time my dn ka value has become what? 0. So I will come out of the loop, and what I will do is I will check if n is equal to 10. Now my temp I have got in this case is 55, and the original number I entered, that was also what? 55. So it means what? My n is equal to 10. So if I am getting the reverse number as same as what? Original number, then I will write what? Number is palindrome. So in this case my 55 is palindrome. So the logic behind this program is what? First what you do, you divide your number till you get the quotient as what? 0. And when you divide your number, you collect two things. In the first variable you collect what? Remainder of the number, and in the second variable you collect the quotient of the number. So you have to keep on dividing your number by 10 till you get your quotient as what? 0. And every time you have to keep on collecting what? Remainders. So this is how basically we separate the nibbles. While separating the nibbles, we divide our number by 10 and then we collect the remainders and what? Quotient. So what we exactly do is, first we separate the number, and after separating the number, then we get some number, and then we check whether that number is same as what? Original number. If that number is same as original number, then you consider your number as what? Palindrome. So what you basically did here is you divided your number till you get the quotient as 0. Every time in the D I keep on collecting what? Remainder, and in dn I was collecting what? Quotient, and I stopped my entire procedure when I got the quotient as what? 0. So in the first attempt when I divided it by 10 by 55, then I got my quotient as 5 and my remainder as 5. So in the first iteration my d was 5 and I got temp as 5 and I got dn as 5. Still my dn was not 0, so one more time I divided it by 10, and in the next iteration I got my d as 5, my temp as 55, and at this time my dn became 0. So once my dn became 0, I stopped and I checked whether my n is equal to 10. So here my n was again 55 and my temp is a 55, so it means what? My number is palindrome. Now the next program is to generate the pattern. Now this kind of program also comes in the exam where you have to print the patterns. Now the print the patterns means what? Now if you see this example, you have to print the pattern like this: 1, then 2, 2, then 3, 3, then 4, 4, 4. So in this case you have to use a loop. You have to use a nested loop. Nested loop means what? A one loop inside the other loop. Up till now we saw the programs. In that programs we were using only a one loop, but in this particular program I will be using what? Nested loop. The one loop inside the other loop. So we'll see how to write such kind of programs. Now see, this is the pattern: 1, 2, 2, 3, 3, 4, 4, 4. Now here I took three variables. They are I, J and N. Now you are telling user to enter a number. Now suppose if user enters 5. So what will happen here? Basically you have taken a two variables, that is I and J. So one is for the row and one other is for the column. Now see, when I generate basically a pattern, I get two things. One I get is row and the other I get is what? Column. So see here, these are going to be rows and these are your columns. Now you are telling a user to enter a number. Now suppose if user enters 4, so it means what? Maximum how many rows you will get? 4. You will get a 4 rows. If user enters 5, then you will get maximum how many rows? 5 rows. Okay, and so on. Now let us take an example where user enters 4. So your n ka value is basically here 4. So what you have to do is, for I is equal to 1, I is less than equal to, now suppose I am considering my n ka value is 4, so I is less than equal to what? 4 and I plus plus. So again I am repeating here, I have taken two variables, they are what? I and J. So one variable is to denote a row and other variable is to denote what? Column. So basically here I here is to denote a row and J is to denote what? Column. So what you will do here, basically you are actually printing a column inside a row. So I started with the row and then I will jump inside the column. So in the first row you have how many columns? You have only one column. Then if you will see the second row, you can see how many columns? Two columns. If you will see the third row, then you can see how many columns? Three columns. And if you will see the fourth row, then you can see how many columns? Four columns. Okay. So I have to start from rows. So for that I am inside the inner for loop now. For I is equal to 1, I is less than equal to 4, I plus plus. Now inside the row you will be displaying what? Column. So for the column I took j, and j is what? My inner for loop, and I is what? My outer for loop. So for j is equal to 1, j is less than equal to I. Now what is I here? Initially the I is 1. So in the first iteration this is going to be a like j is less than equal to 1 and j plus plus. So how basically it will happen? This is the outer for loop and this is the inner for loop. Outer, inner. So first what I will do, for I is equal to 1, 1 is less than equal to 4, yes, then I will jump inside the inner for loop. Now what is written inside the inner for loop? J is equal to 1, 1 is equal to 1, yes, then what you will do, you will print the value of I. Now what is I? I is 1, so I printed here I. Now what will happen? J will get incremented by 1. So now this iteration here j will be 2. 2 is not less than equal to 1. So you will come out of the inner loop and then again you will jump inside the outer loop. So first it will finish the execution of the inner loop, and then again once the condition inside the inner loop gets false, again it will jump inside the outer loop. So again it will go out and it will jump inside the outer loop. Now here I ka value will get incremented by 1. So here I will be a 2 now. 2 is less than equal to 4, yes, 2 is less than equal to 4. So again you will jump inside. Now what is written inside? J is equal to 1. Now in this case you have to execute your loop till your j is less than equal to 2, because my I ka value has become what? 2. So what you will do here, basically j is equal to 1, 1 is less than equal to 2, yes, so you'll print I. Now what is the value of I? 2, so you'll print here 2. J plus plus, you're still inside the inner loop. Now j plus plus means what? J was initially 1, now at this time it will become 2. 2 is equal to 2, yes, so one more time you will print I and you will print this 2. Okay, now your j will become a 3. 3 is not less than equal to I, so you will come out of the inner loop and again you will jump out the outer loop. Now in the outer loop your I ka value will get incremented by 1. So it was in 2, now it will become 3. 3 is less than equal to 4, yes, so again you will come inside the inner loop. Now what is written inside the inner loop? J is equal to 1, and this time you have to execute your inner loop for j is less than equal to 3. So j is equal to 1, 1 is less than equal to 3, you will print I. Your I has become what? 3, so you'll print 3. One more time your j ka value will get incremented. This time it will become 2. 2 is less than equal to 3, yes, one more time print I, that is 3. One more time it will get incremented, so j will become 3. 3 is equal to 3, yes, so again you will increment, again you will print I and it will become 3. Now one more time it will become incremented, so it will become 4. Now my 4 is not less than equal to 3, so you will come out the inner loop, again you will go inside the outer loop. In the outer loop, now my I ka value will get incremented by 1 and it will be a 4. So again you will get inside the inner loop. This time you have to execute your inner loop for j is less than equal to 4. So again you will start from 1, 1 is less than equal to 4, print I, that is 4. J will get incremented by 1, j will become 2. 2 is less than equal to 4, yes, print I, one more time 4. Again you will get incremented the value of j, so it will become 3. 3 is less than equal to, 3 is less than equal to 4, yes, so again you will print I, it will become 4. Now at this time your j will become 4, 4 is equal to 4, one more time you will print 4. Now your j ka value will get incremented and it will become 5, your condition will get false, you will come again inside the outer loop. Now again in the outer loop your I will also try to become what? 5, and 5 is not less than equal to 4, and you will come out of the everything and you will get this pattern to be printed on your screen. So what basically I did is, I started from the outer loop, then I jump inside the inner loop. You have to be inside the inner loop till your condition gets satisfied. Once your condition gets false, you will come outside the inner loop and again you will go inside the outer loop. So you have to keep on doing it till your condition gets satisfied. And see, here I have written end L after the inner loop. Why so? Because I want my numbers to be printed on the separate line, so that's why after the inner loop you have to print end L and then your outer loop will get closed. So this is how we draw, this is how we write a program to draw a pattern. You may get a different type of patterns, but you have to keep it in your mind. When we basically draw patterns, we use nested loops, and this is the basic program. This is how we go while writing a program to print such kind of patterns. So I hope you have understood all those programs. We saw a program to generate a Fibonacci series of 15 terms. Then we saw a program to check whether my number is prime or not. Then we saw a program to check whether my number is palindrome or not. And in this program we saw how to generate a pattern. So I hope you have understood all this program. Thanks for watching this video. In the next video we will study nested if else and else if ladder. Thank you.